Okay, this video shows method 2 for annuities treated as a geometric series. Now, as I said before, method 1 is a great method in this particular exercise. It works very well. It's fairly easy to understand. But method 2 works with all examples, so that's why I prefer it. So I'm doing the exact same question. $300 is invested at the end of each month and earns 18% per annum, paid monthly. How much will it be worth at the end of 15 years? So again, our R is that 18% divided by 12, being 0.015. And our N, it's 15 years, so 15 lots of 12, which is 180 months. And that's per month. So these are both months because everything has been asked about months. Okay, so in this one we have A1 is the amount at the end of the first month, which is quite simply the $300 that is put in at the end of the month. It gets no interest on it. We're going to build up from there. We're really going to use our recurrence relation here. So our A2 is the amount from the first month with some interest, okay, just like compound interest, plus the $300 that's deposited for the next month. Okay, now it's really important to write it like that, to write that recurrence relation. So that's 300, 1.015 plus another 300. Now, I'm not even going to write at this point what that answer is. I could put it in my calculator if I wanted to, but I'm not going to. Because it's 15 years and 180 months, I have to do this 180 times. So I'm just going to leave it like that because I really need to build my geometric series. You could be tempted to factorize this because they've both got 300. Don't factorize it. If you factorize it, you will get yourself confused. Okay, let's just go straight to the next month. So our third month is our previous month with some interest on it, plus another lot of 300. Now, here is one of the most important tips I can give you for this exercise. This A2 here, we need to replace with this number here. So put brackets the size of that. That's our A2. Now, what I would do before I fill that in, I'd actually write out the rest of this. So I'm rewriting this line, but brackets instead of A2. This tip will really, really, really help you in the long run. Okay, so A2 brackets times by my 1.015 plus my 300. And then fill in the brackets. The problem is people write this and then they forget to write the rest of it. Okay, so let's just fill in the brackets with our A2 value. So 300, 1.015 plus 300. And now the next step is to expand the brackets. Okay, if we start putting things in calculators, start factorizing, anything like that, we're not going to see our geometric series. But we just expand this bracket times 1.015. So we've got this value here times 1.015. So we've got the 300 1.015, and we're timesing by another 1.015, so that becomes squared. Plus, we've got this 300 times by that 1.015 as well. Plus we've got this 300 at the end. Now what we're starting to see here is the building of a geometric series here. Okay, so it's a series because it's got plus signs, not commas. It's geometric because it's got a rate at each one. So our next step is to write a formula for when n equals 180. Now we could write a formula for an, but I'm just going to go straight to writing a180. But we can follow the pattern. So we always have 300 on each term. Our first term, our power is 1 less than this number here. So 1.015 to the power of 179. Our second term, it reduces by 1. That was power 2, this is a power of 1. So 300, 1.015 to the 178. And that's going to keep going plus dot dot dot, I should only have 3 dots there really, plus, and the very last one is 300, okay? And remember from our previous, from method 1, this now becomes exactly the same as method 1. We have to flip it round. So we write the last term first. So we've got 300 plus 300 with 1 lot of interest on it. Okay, that would be a power of 1, that's the term here. Plus 300 with 2 lots of interest on it, plus dot dot dot, plus our very last term is 300 with 179 lots of interest. But remember, our n is 180. There are 180 terms in this series. So if we want to add all that up, it's a r to the n minus 1 over r minus 1. Our a is our 300, our first term. Our r is our rate that we're multiplying by, which is that number there. It's a little bit confusing because we did call r up here this number, but this r here is different from that r there, so just be a little bit careful with that. This r is this number here, 1.015. Okay, to the power of n, our n is 180. That's 179, but there are 180 terms here. Minus 1 over that 1.015 minus 1. And if we put that all in our calculator, we get exactly the same answer as we got using the previous method, 9938646. Okay, this method is a lot to get your head around, but I would really try to understand it and follow what's going on here and practice it over and over and over and over again.